Welcome to Module 5, Lesson 2, Rewriting Percent Expressions. So we focused a lot on how to find those pieces, so how to find the percentages of, and how to find that percent increase and decrease, and now we're going to continue to do that, but now we're going to work on how to write those expressions. So understanding how rewriting expressions in different forms can help us see how quantities are related, and then how to solve multi-step real life and mathematical problems, and then how to apply properties of addition to calculate with numbers in any form, and assess reasonableness of our answers. All right, so here we go. So first, to make a profit, stores mark up the price on items that they sell. And at a sports store, they buy skateboards from a supplier for S amount of dollars. And we want to know, what is the retail price for skateboards that the manager buys for $35 and $56 after a 42% markup? All right, so first and foremost, what is the question? So we want to know, what is the retail price for skateboards that the manager buys for $35 and $56 after a 42% markup? Well, first of all, the retail price is what you and I purchase it for. We talked about this, about how markup is because stores work for profit. They want to make money because they have to not only pay their employees, but they want to make money because that's how the world works. And so they have a retail price, which is what they sell their products to consumers for, so that way they can make their money. So the manager, the person who is running the store, they buy the skateboard for $35. So they're not going to turn around and sell it for $35 because then they don't make any money, and then they can't pay their employees, and then people are not going to be very happy. So it's important to note that they bought the skateboard for $35 and for $56. And it's important to note that it's a 42% now markup. In this case, markup isn't just an important word, it's our to-do word, because it's telling us that we're going to be adding whatever that piece is, okay, whatever that number is. And then a sports store buys skateboards from a supplier for S dollars. So what we're going to do first is we are going to create an expression that is going to be a very general expression. So it's not going to include the 35 and the 56. It's going to be general. It's going to just be for any number. So since it's going to be for any number, it's going to include the S. It's going to include that variable, so we can plug in any number. So we can plug in the 35, 56, 89, 100, whatever the price may be for that skateboard. All right. So first what we're going to do is we're going to draw a bar model. So I've kind of drawn these a little bit in our other lessons. So first what we're going to draw is we're going to draw the price of the skateboard. So in this case, the first bar is the total price of the skateboard. So this first bar is the total price of the skateboard, which is represented by the variable S. The next little piece that we draw is our 42%. Now notice 42% is a part of the cost of the skateboard. It's not quite half, okay, but it is represented by 42 hundredths, because remember, 42 is not the number, okay, it's 42 per 100. So as a number, it's 42 hundredths, and it's, in order to find what that number is, we have to multiply it by S. Okay, so visually what's happening is we're kind of taking it, so it's like this. So we're taking it, we're saying, okay, well, we have this whole skateboard right here, and we want to know this much of it. Okay, and I can actually go here. What I'm going to do is I'm going to make this a different color. And when I make this a different color, see how well I can do this here. Test my skills. Click on this. Let's see if I can fill it with, not that. I want, actually, let's just do it that way. So let's fill this whole thing here. Let's make it green. Green's fun. There we go. All right. So we want to know this much of the skateboard. We want to know how much that is. What amount of money is 42% of that cost? And then what we're going to do, once we figure that out, we are actually going to subtract that. So we're going to take that total price of the skateboard, we're going to add that because it's a markup. We're adding that to the cost. So that way this much, so this price of the skateboard is what the manager had to give to another company. And then this piece right here, this is the extra that he's charging us as consumers, so he gets to keep that. He or she gets to keep that. Okay, so he's going to add that to his cost to make the retail cost. But now we can't just, throw whatever number on there we want to. We have to figure out what is this number represented by this green space. So there's a couple ways we can do this. So before we did say that we can take S, the price of the skateboard, and we can take 42% and change it to a decimal and multiply it by S. So we take 42 hundredths, multiply it by S, the price of the skateboard, and then add it to the price of the skateboard. Okay, so as an expression, it would be S plus 42 hundredths times S. Now, S, because it's only one skateboard, we would say is the same thing as 1S. Okay, so we could say that these two things are exactly the same. We can say S and 1, these are the exact same expressions, except for instead of just having S, we have 1S. Because S and 1S would equal the same thing because 1 times S equals S. So then, now I can add these two things together, and I know that 1 plus 42 hundredths is equal to 1 and 42 hundredths. So what we're saying here is that this expression that we used, where we took the price of the skateboard, and I'm going to write this in black, and I'm going to make this a little bit bigger so you can see it. So if I took the price of the skateboard and added the 42 hundredths percent of this, okay, so if I took S plus 42 hundredths times S, doing that is the same thing as just taking 1 and 42 hundredths times the price of the skateboard. So both of these expressions, even though they're different, both of these expressions will get me to the same answer. Okay, because of this connecting piece right here. So let's take a look at how this works, because I can see how this can be kind of confusing right now. So let's use it and see how it works by using the 35 and the 56. So first let's plug in the 35. So if I take that $35 for the skateboard and plug it in, I see that I have 35 times the 42%. Okay, and then I'm going to add that to, and actually let me rewrite that so it follows the flow a little bit better. So we said 35 is the price of the skateboard plus the 42% times the $35. Okay, that follows the flow a little bit better. Okay, so now when I do that, I get that there's $35 plus $14.70 because 42% of the price is going to equal $14.70. So if I take my calculator and I do 35 times 42 hundredths, I get $14.70. Remember, we have to add that 0 to the end because it's money. So now I'm going to add that to that original cost, which was $35, and I get $49.70. So the retail price, so what the manager is going to sell it to us for, is $49.70. So that's using this expression right here. Now, I can just use this expression right here, the 1 and 42 hundredths times S, and it should get me to this same answer of $49.70. Okay, so think about it. He still wants me to pay the $35, but he also wants me to pay more. So it's going to be it should be more than so it makes sense that this number here that I'm going to be paying, I'm going to be paying more than 100% of the price. Because paying 100% of the price would mean I would pay just the $35. If I paid 100% of the cost, I would pay just $35. However, he wants me to pay more than 100% of the cost because he needs to make money. So he wants me to pay 100%. So remember, 100% would be like this one here tells me that it's above 100%. But then he wants me to pay more than that 100%, which is why we have this extra over here. So if I take and plug in my numbers, so if I take that 1 and 42 hundredths and multiply it by the $35 that the skateboard costs, you'll notice that I get the $49.70, which is exactly what I got when I did it the other way. Okay, so again, I have two different expressions that got me to the same answer. All right, so let's try it again. Let's try it with the $56. So again, I can start with the $56 and multiply it by the 42 hundredths. Okay, and when I do that, so $56 times 42 hundredths, that's going to give me $23.52. Okay, so $23.52 plus 56. So plus 56, let me just double check here. Yep, so $79.52. So that manager is going to sell me that skateboard for $79.52. So that was using, again, this expression right here, the S, the plus 42 hundredths times S. Now again, I can also use the 1 and 42 hundredths times 56, and it should give me the same exact price of $79.52. Again, it makes sense because that, again, the manager wants me paying 100% of his cost plus more. And we said with a decimal, when we have a decimal of 1 as a percent, that is equal to 100%. So anything that is a decimal that is So anything with a decimal that is above 1, so I'm trying to think of the best, so above 1, do this. So anything above 1, there we go. That's going to be a percentage that is above 100%. Okay. So with markups, it makes sense because markups are supposed to make the price higher because they want to make money. All right, so let's go ahead and take a look at this. The markup is changed to 34%. So how does the expression for the retail price change? Well, instead of it being 42 hundredths, now that percentage has changed to 34. So instead of 42 hundredths, it's 34 hundredths times S, okay, plus S, or it's going to be 1 and 34 hundredths times S instead of the 42. Okay, so when it's a markup, you're always going to have that 1 in front because they always want you to pay 100% of the cost. Okay, that might change though because if they want you to pay more than 100% of the cost, then this 1 is going to go up. All right, so now it's your turn. So I want you to take a look and I want you to try these two problems by yourself. Number 3 is actually going to be a little bit complicated, so I'm actually okay if you do number 2 by yourself. Come back and check your answer, and then we can talk about number 3. All right, so number 2, you should have found that Rick buys remote control cars to resell. He applies a markup of 10%. So rewrite the 2 expressions. So the first expression would have been, I used R for remote control cars. So R times 10% plus R. And then the other expression would have been 1 1/10 times R. And then you should have gotten that he sells the remote control car that he bought for $28. He sells that remote control car for $30.80. Okay, and then here's how you plugged it into your equation. And that's how you should have gotten your answer. Now, for number 3, they're tripling the price, right? So if they're tripling the price, it's not that they want a 300% markup. It's going to be a 200% markup. And here's why. So they're paying the price of the one clothing item. Okay, so there's the 1. But then, so that's the 100%. But then now they also want the 2, they want you to pay 2 more. So there's where you get the 3. Okay, so it is a little bit different here where you're thinking, okay, 200% would be doubling it. But you have to remember, doubling it is when you are doing a 100% markup. Okay, a 100% markup means that you're completely doubling the price. So whereas if they had that $35 skateboard and they sold it for $70, that would be a 100% markup. Okay. All right, so here we go. So a discount store marks down all of its holiday merchandise by 20% off the regular selling price. Find the discounted price of decorations that regularly sell for $16 and $23. Use a bar model. Okay, so first and foremost, we have our full price holiday merchandise that's represented by the big bar. And then the 20% off that's represented by the little bar. And again, it looks like this, where we're taking the big minus the little. However, I'm going to change this one up a little bit. Okay, so you still have this here, but I'm going to move it off to the side. I'm going to show you another way that we can actually draw this. All right, so you have this large bar where you have your full price. All right, and then, actually, let me grab this one. So here's your full price. And then inside of that full holiday price, you have your 20%. So you have your line here where you have 20%. Right, so that little spot here is 20%. And bear with me because I don't have the best drawing tools right now. And then this chunk right here, so this whole thing from here all the way to here is the full price. And then this little chunk right here is 20% of the full price. And then now this right here, this is where you're going to get your difference in price, okay? So we're going to kind of take a look at what this is once we take a look at our expressions down here, okay? So this is what you have left at the end, because what you're looking at here, so you want to know so find the discounted price. So in this case, you have, where's my box? You have 20% and you have 20% off. So off is going to be circled because it's telling us that we're going to subtract. Okay, so it's important that it's a markdown because that's also telling you that it's going to go down. All right, And then it's going to be important later that it is $16 and $23 that we're working with. But first we want to make a general expression so that way we can plug in any price that we want. So in this case, you know that right here, this is actually what we should end up paying at the end. Okay, if this is what we're taking off, this right here is the amount that we should end up paying. Right, so if you think about it, right here, you guys know how to find this. You know that this is the original price and you want to subtract that 20%. And to find that 20%, you have to take that 20% and multiply it by P. Okay, or 20 hundredths and multiply it by P. Now, this time though, if you take that P and remember that it actually is 1 times P, and subtract it by 2/10 or 20 hundredths. When you do that, because you're subtracting, you get 8/10. Okay, so now your number's going down because you're subtracting. So logically, this makes sense. So up here, this is 2/10, so what's left up here is 8/10. So what's left here is you either have P minus 2/10 times P, or your second expression, which is you can take 8/10 and multiply it by P. So again, we have two different ways where we can solve this problem. We can either take the original price and subtract that 20% that we find, or we can just find 80% of the price right off the bat because that's all you're paying. You're taking away 20%, which means you're paying 80%. Okay, if you go back and take that logic with the markup, not only are you paying 100%, you're paying 100% and 42%, so you're paying 142% of the price. So that makes sense that this is 142 or 1 and 42 hundredths here because as a percent, it's 142%. Again, just another way to look at it. All right, so if we take a look at this one here, I'm just going to show it to you all at once. Okay, I don't want to slow us down anymore. So we have 16 minus the 16 times 2/10. When you do that, you get $3.20, and when you subtract, you get $12.80. Again, if I just take it and find 80% of the 16 right away, I get $12.80. So two different ways, same answer. However, you have to be able to give me both of these expressions throughout this unit. So you have to be able to show me that these two expressions are equivalent, and you have to be able to give me and use both. In real life, when it comes down to it, whichever way you're comfortable with and whichever way you like is completely up to you. But it is my job to make sure that you can not only find but use both of them, practice with them, and then choose which one you like best. All right, so here you have the $23 again. When you use it and take the 23 and find 20% of it, you find that that's $4.60. When you subtract that from 23, you get $18.40, and that's how much you pay. Or you realize you can take $23 and find 80% of it, which is again $18.40. All right, so the next problem asks you to take a look at the problem and see what you notice about the expressions from example 1 and example 2. So the single term. So the single term from example 1 was 0 and 42 hundredths S, and the single term from example 2 was 0 and 8/10 P. Okay, and actually, I'm sorry, it wasn't 0, it was 1. So what you should have noticed is that one of them was above 1 and the other was below 1. Okay, so this one, again, above 1, this one, below 1. And as you notice here, I said that makes sense because when you're trying to mark something up, you want somebody to pay more than 100% of your price. you want them to pay what you paid and then some. Right? So it makes sense that you want that price to be inflated. However, when you're doing discounts, they're going to pay less than, they're going to pay 80% of that retail price. So that's going to be marked down, okay? But again, this is 80% of the retail price. This isn't 80% of the buyer's price. So the difference here is like with that skateboard, I'm not paying 80% of that $35. I'm paying 80% of whatever that retail price was, which I think we said was like, for one of them, it was $79. So I would be paying 80% of that. So that's where that difference kind of comes in. All right, so again, noticing that when it's a markdown, your single expression, your single term expression is going to be less than 1, and when it's a markup, it's going to be above 1, or 1 or above. All right, for this one, I would like you to try these on your own, and then again, when you come back, we'll check your work. For your bar model, I'm fine with you doing either interpretation. I know that I gave you 2 versions. Whichever one you're more comfortable with, I'd like you to go ahead and do. When you come back, we'll check your work. All right, so this is what you should have gotten for your answers. Again, I'm comfortable with either of these representations. I'm actually a little bit more partial to this one. I think it gives you a better visual because it shows you that this is what's coming off. I actually kind of like the idea then too of saying, okay, well, this is actually coming off at this point, but I mean, it's kind of up to you guys how you want to do that, whatever makes it make sense in your head, but you have to have these expressions with it. You have to have these indicators to say what each piece represents. Okay, so that bicycle shop is selling the bicycles for a price of B because all the bicycles have different prices. And they're marking those prices down by 24%. Again, those are retail prices, not their prices, okay, not what they bought them for. And so first, here's the representations of the problem. And then now I want to know what was the single term, so single term expression. So in this case, I would have to take and figure out, okay, well, I have 1B minus 0 and 24 hundredths B. So if I take that 1 minus 24 hundredths, I should have found that I got 0 and 76 hundredths B for my answer. Okay, so Jane sells pillows, and for a sale, she marks them down by 5%. 5% as a decimal is 0 and 5 hundredths. Okay, so I know that as an expression, I can do P minus 0 and 5 hundredths times P, or I can do 95 hundredths times P. I'm comfortable. You do not have to write the 1 in front of the P, but if it helps you for converting it to that second expression, that is fine too. Then if you are, if the original price of the pillow was $15, you would take 15 and you would multiply it by 5 hundredths, and then you would subtract that from 15, or you would just take 95 hundredths and multiply it by 15, and you should have gotten $14.25. Okay. Again, I want you to keep practicing with these. You have a couple of problems in your guided practice. All right, so you have 1 through 11 here. And as always, if you have any questions, please be sure to write them down or email me so we can go over them in class.